Hello everyone again and welcome. So today we'll be continuing with descriptive statistics. So let me launch our R Studio. It's launching. All right. So the first thing we are going to do here, I don't really need all of this what we have been working on. So I'm going to clear this. Then I can just put here as a title. I'm talking about descriptive statistics. Now we use this hatch symbols if we want to like write comments in R. Now, first thing I want us to do, we come to file. I want us to be able to save this project we are working on. We can take save as, then we can go to our desktop. We locate. I will say you just create a folder for this. I already have folders created. It can be on your desktop. It can be on the location on your drive. Doesn't matter. I open summary. I go to this. This is the course. I'm just going to say this script. Just save it. Going to save it. Here it's going to show you, every time whatever thing we are working on, we are going to be saving it. So first things first, I did mention yesterday about the msleep data. That is what we are going to be using. We are going to be looking at descriptive statistics, which is a way we can use to summarize data, whether the data is numerical or what is categorical. For numerical data, the way we summarize this, I did mention as if we take summary of any numerical data, you can have the mean, you can have the median, you can have the lower quartile, which is Q1, you can have the upper quartile, Q3, you can have the maximum and the minimum value, which is very, very significant. And you can draw some conclusions. If, for example, the age a vector that we had, you can take, or if the average age is for a particular class is maybe 80, you can say, okay, averagely in this class, we have the average age at this. You can make those conclusions. But today, as I did mention, we are going to be using that msleep data. We are going to load the ggplot2 library. That is where that data set is found. One thing I want us to do is for we can read more on that data, we can just do msleep. Yeah, it's going to show up, and then we can read about it. This is here everything about that data on this panel where we usually have our graphs. It is a data frame with what we have 83 rows and 11 variables. One thing we have common, there are different ways we can view. We can just do view of that data. We can do msleep. Let's see. If I just run this, we can view that data. This is, so when you do view, it's going to open on another tab just like an Excel sheet. You can scroll through with your mouse and then look at, that data. So we can see here that that data has, for the numeric variables, we can have the total amount of sleep that people have, and then we can have this, the sleep cycles and all those things. You can see that at some point we have missing values. You can read more about this data set here. We have the sleep underscore REM is like the remaining sleep time in hours, total amount of sleep in hours, and so on. So I don't really want this. I can take this out. Do that. You can also do head just to view the first 6 rows, as I did mention the other day, of this msleep of this data. Just do head is going to show us the first string. You can also do tail. You can do, if you do dimension, just to see whether how many rows does this data msleep. You run this down here, you should be able to see that the dimension here you are going to see is made up of 83. The rows comes before what? Before the columns. Also, you can try to do string here. str will give you the number of numeric attributes we have in this data, as well as what categorical. You can see here it says the name is a character, where we have cheetah or orc, monkey, and so on. And then also we can see that the total amount of sleep is a numeric variable. Some are categorical, just like characters. So that's what we can do with that. Also, you can do names. You can do names, msleep. You run this and see what you get. So here it's just going to give us the total. That is the columns in that data, which I did mention the 11. If you count this, we should have what? A total of 11. And so As I did mention, you can do what we'll be looking at is what just to do like a summary. If we want for descriptive statistics, there are different ways. When we have what we call numerical data, numerical data. You can read more about numerical data, just like data that is made up of like numbers. With numerical data, you can have discrete and continuous. With discrete, it's just like the count of, for example, the number of cars occurring that come up in, for example, at the gas station. Those ones are discrete numerical data, and then continuous are something like ages of people. No, not really ages of people, because ages you cannot say 8.5. Some people will say 8.5, so age can fall within that. But the good example of continuous numerical data could be something like the weight of somebody. It could also be the height of somebody, some things like that. What kind of thing can we do with this numerical data? How do we summarize this? We can summarize this by using calculating the mean, the median, the standard deviation, and so on. So for example, remember I did mention the other day, you can try to call this, since we already have that M-slip, you can just do a summary. Let's just do a summary of that M-slip and see what we have. If I do a summary of that, you will see that it will only perform this only on the numeric variables, because on the numeric variables, we can get the mean, we can get the median, and so on. So that's why you see that the sleep remaining, the sleep cycle, the awake, all of this. If you go back and run back this string, you will see that all of these numbers are numeric. And we can also see some missing values. We are going to see how we can take care of these missing values as time goes on. Another thing we can do here, since we already know that some of these values are numeric, if I want to calculate the mean of the total amount of sleep, I can just do M-sleep, and then I do the $sign, and then it's going to give us the different types of columns in that data. The total sleep, you can do that, and then I'm going to run it. I see the mean of the total sleep in hours is like 10 point something hours. We can also do median. I don't want to run it up here. Let me just type that median here. Median M-sleep, and then let's see, take this total, and then we run it. You see, in all of this, we can keep doing this, whether you're calculating. So one thing you need to know here with numerical data, as I did mention, especially continuous data, most of the times we can calculate the mean, we can calculate the median, we can look at the mode, we can also look at the standard deviation. You can try all those things. We can also look at what we call the variance. You can look at the different quartiles and so on. Now, there is another thing you can do. We can also calculate the sum. So for example, remember we can count the number of times that each thing occurs in like, especially with categorical data. Also, if I want to get like for relative proportions, if I say I just only want the mean M-sleep, want the mean for that total where all is greater than 8. So what I'm trying to do here is I'm actually calculating the mean for this, but I only want the case those means that are greater than 8. So if I do that, let's see what we have. We can only have that the total, the proportion of means that are greater than 8 is the proportion is only it's like 73 point something. Let me say 74%. That is, you're trying to look at the proportion of the mean of the proportion of the total amount of sleep that are greater than 8. So one thing we can also look at, as I did mention, we can look at the correlation, which measures the associational relationship between two features. You can look at M-sleep, which is the correlation between the total do $sign, the total sleep that people have versus versus the remaining sleep time. Let's look at that correlation and see. You see here it is giving us something like an NA because we have missing values there. We are going to see how we can take care of this. If you want to remove and calculate, you can use something in R where we have, say, use only the complete observations. Complete dot ops. Now, if we run this, you see that we are able to get what? The correlation between these two, the total amount of sleep and what is remaining sleep time. You can read about this in hours. It's just like what? Approximately 75%. So now, what about when we have, like in the case of the categorical attribute, like the categorical attribute that we have, how do we get a summary, like the descriptive statistics when we have categorical data? Now, the categorical data, as I did mention in there, we can try to run this to see the categories that we have here. We can see that we have different, like the names, it's like different types of cheetahs, how they run, total amount of time that they can, you can track, or they sleep. So now we can do this by what we call contingency tables. You can read the notes I sent out for week 1 and week 2. As I did mention, we are going to have those notes. I'll go live on Saturday. I'll be sending either Zoom link or Microsoft Teams so that we can log on, and then we can look at how. So we can see here that here we have this VOC. We can read about this. What is it all about? Let me look at that future. So like is carnivorous, whether those animals are carnivorous, they are omnivores or what, or herbivores. So we can say we see carni, oni, and herbi, and what, oni, and so on. So if we want to count the number of those animals, I can just do table, since that variable is categorical, and we do mSleep, and I do dollar. I just want to look at 4. If I do a table, since those ones are categorical, you see that the total number of carnivores here in this data, we had what, 19. For herbivore, we had 32, and then insect, we have 5, and then omnivore, we have like 20. So that is it. How you can deal with especially categorical data. You can also do at what proportions. Instead of looking at just that table, you can calculate the proportions. We can do proportions. We are going to see this, especially in some of the exercises that we'll be doing. So I do proportions in bracket. I pass in, I want a table, but in that table, I will do mSleep, and then I pass in normally my dollar, and then I pass in the same thing here, but here we're having like counts, but this time around we are going to be having proportions. So if I run this, you see that instead of those counts, we are now having what, proportions, right? So calculating this proportion, what you have to do is we have to sum all of this, and then we try taking 19 divided by the sum of all of this. That is when we are going to be getting all these proportions that we have here. Now we can also count, use tables, what we call a true like a contingency table, where we can have 2 categorical variables to get their count. Like if I do table and I want to see the count for what, mSleep, those vod, and conversation. Okay, if I run this, what do we have? We can see that for conversation, we have the different types. We have CD, we have different types. Like we have like how many of them? 1, 2, 3, 4, 5, and what, 6. So it's going to say, okay, for carnivore, how many of those carnivore had a conversation based on what, CD? They were just what, 1. So we can do this, but if you calculate the total amount here, you will see that it will go to the total amount that we had initially here, which was like 19. You can try that out. And then also we can do same when it comes to proportions and so on. So what I want you to try as exercises, look at that book. If you go to under exercise 2.11 for the link to that book that I sent, Introduction to Modern Statistics with R, try to do that exercise where you have another data is Palmer penguins. Try to do these exercises and see how whether you can complete them or not. That is it for today. For the next video that I'll be posting, it will be based on what, how we can plot whether it is numerical data or what, or categorical data. Keep following me, guys, for more of these tips, and I believe you will learn a lot from this basic introduction to R and statistics to become a better data analyst as well as what? A better data scientist.